Alright, so last one. We're going to do lesson 63, problem C. And the question says graph r equals 4 sine theta. Now, we can do this in 2 seconds by saying that really what I want you to be able to do is I want you to go through and get a graphing utility and you type in the graph, the function, observe what the graph looks like, make some changes, change it to a 3, a 2. Oh, I missed something here, I'll fix this. Make some changes and then observe what happens. Alright, it's supposed to be 2 theta. Alright, so that's all I'm looking for. And then I want you to be able to, kind of know what the different shapes of these functions are, and be able to associate them with the actual equations. Okay, so let's try this one. So what we're going to do is we're just going to plug in some angles and do times 2, whatever that angle is, times 2. What would the sine of that be? Multiply it by 4, and then that will give us some number that will be our radius, and then we'll put a point, and then we'll pick another angle. Multiply it by 2, take the sine of that angle, multiply by 4, it's going to give us another, and then we're going to see that there's some sort of pattern here, there's some sort of shape that starts to form as we take more and more angles. Okay, so let's think about what's going to happen. The first thing I notice is we've got this sine of 2 theta. Now, don't worry too much about that 2. We'll talk about it in a minute, but basically what that means is that we're just plugging in angles, and the only angles we can plug in are going to be the angles from 0 to 180, because each one is going to get multiplied by 2, and so that's going to take us all the way to 360. So we're going to plug in those angles. Now, we're going to plug in bigger than angles than that, but we're just going to keep going around the circle, right? The sine of 360 is the sine of 180, is the sine of 0, and so on. So we're going to keep getting the same answers over and over again. If you think about the the sine function, it just goes up and down, right? Just goes up and down like this. And the highest it ever gets is 1, and the lowest it ever gets is -1. And so no matter what we plug in here, that's what we're going to get, numbers between 1 and -1. So that it means that the radius, remember the radius is the distance out from the center, can never be more than 1 or less than -1, but -1 just means go the other direction. So the radius can never be that, only except that we are multiplying our answers for sine by 4. So that means that our radius will be 4, because we'll take our sine, whatever it is, and the biggest it can be is 1, and 1 times 4 is 4, and so that's the biggest number we can get. 1, 2, 3, 4. 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Alright, so we can say that our graph is going to be somewhere within that circle. Now, that circle is not the graph, right? Because the sine of the sine isn't uniformly 1 all the way around, but the graph is going to be somewhere within that circle. Now let's try to get specific. So first of all, what's the sine of 0? We'll graph in blue. Well, the sine of 0 is 0. So when when we're going kind of in this direction, the radius is going to be 0. When is the sine equal to 1? Well, that's 90 degrees up here, right? And so when we're going in this direction, it's 1. But we're multiplying by 2, so actually we're going to get the sine of 90 degrees at 45 degrees here. So this is going to be where we hit the biggest, kind of our limit out here. I apologize, didn't get the cough button in time there. So think about it, from 0 to 45 degrees, which is, doubling, you get 90. We're going to be moving from 0 radius up to a radius of 4. So just kind of getting bigger and bigger as we go along. And then that's the biggest. And now from there on out, we're going to start going down, back down to 0. Now, where is it going to hit 0? Well, remember, the sine function hits 0 at 180 degrees, but we're doubling our angle, so when we plug in 90, we're getting the sine of 180 degrees. So it's going to be at this angle, 90 degrees, that we're back to 0. So we're going to keep on going along and just kind of going down. So we get this kind of, well, pedal shape, maybe. It's kind of got a curve to it, goes out to a distance of 4, and then kind of curves back down to 0. Now, notice that in the sine curve, after that, you start going negative. Well, what do you do when you have a negative radius? Well, you just go the opposite direction. So while we're going to be doing angles in this direction, our radius is going to go the opposite way in this direction. But the same thing is going to happen. We're going to start going, this way, and we're going to get bigger and bigger until we get to the kind of the 45 degree mark again, right? 180 plus 45, or 90 plus 45 degrees. That'll be the furthest out we go, only we're going the other direction, so it'll be out here, and then we're going to go smaller and smaller. So we end up with a curve that looks like this. And then, once we've got back to 0, we start going out again, and that's when we're going these angles here. So for those angles, we're going to get bigger and bigger until we get to that kind of 45 degree mark. Again, that's 180 plus 45. And then going toward the 270 mark, we're going back to 0 again, and then we're just going to do it all over again. This time our angles are going this way, but that's describing this bottom half or negative half of the sine curve, which means that our radiuses are negative, so they're actually going the opposite direction. And so the graph ends up looking like this 4-petaled flower sort of thing. And it kind of fits within this circle with a radius of 4. Alright, so that's what's going on specifically here. I don't want to get too hung up on that. I'm not by any means going to ask you to be able to describe that on a test. What I do want you to be able to do is to type in as many kind of examples as they give you of the different types of polar equations. Type them in, see what what your graphing utility spits out. Desmos Grapher is really good. So if you go to Desmos Grapher, type that in your search engine, that'll give you a really good graphing utility that works nicely. There's lots of them on the internet. So on the computer that works, there's lots of apps you can download for graphing, and they'll all do polar coordinates. You just have to kind of switch it over to polar coordinates and it'll do it. So have fun with this. Thank you for watching.